Here's a common physics mistake from nuclear physics. Question from the 2020 OCR Exploring Physics paper 2, and most candidates taking that exam found that question difficult. So this question is all about modeling. We have a table here of the time t and the number of radioactive nuclei that are remaining at that time. For instance, we start with 2000 and some of them decay, and we have 1900. We're modeling this with the equation delta n over delta t is equal to minus 0.5 times n. The trick with those modeling questions is to use this equation to fill in any blanks in the table until we get our result. And in this case, we're looking for the number of radioactive nuclei that are remaining at 0.3 seconds. So over here on this table, we have the number of nuclei that are decaying after 0.1 seconds. Well, this is actually our delta n, which is on this part of the table. So we can just rearrange this equation for delta n. We're going to find this equal to 0.5 n times delta t. Well, delta t is just 0.1 in this equation, so I'm just going to write 0.1. So for our second row, our delta n will be equal to minus 0.5 times n, which in this case is 1900 times 0.1. Let's plug this into a calculator. So this is equal to minus 95. So the number of particles that have decayed is actually just 95. This, of course, leaves 1805 particles remaining. Now let's repeat the same calculation. So rather than 1900, I'm going to say that this number here is 1805. Let's plug this again into a calculator, and this will give us minus 90.25, but because we're dealing with whole particles, I'm going to write this as minus 90. So this means that we're losing 90 particles. Okay, so how many have we got left? This number here will simply be 1805 take away 90, which is going to give us 1715 particles, and the correct answer is C. Now this is a tricky calculation question, but to ensure that we get maximum marks on the exam, we shouldn't lose any marks on describe, explain or show questions, and this video will show you just how to do that.